Okay. Yeah.
Okay. Are you guys able to see my screen?
Yeah. We can.
Okay, okay. That's good. So let's get started. I am Neha, and today we are going to continue our discussion on partitioning. So a quick like a kind of agenda for today, like we'll quickly recap on previous weeks what we discussed on partitioning for like few minutes, so that just to warm up or like few folks which missed one or the other sessions. And then we'll discuss mainly about rebalancing partitions. There are two strategies there, fixed and dynamic. So we'll discuss on that, and then we will touch base on the request routing. So let's get started. And guys, please make this session interactive. Any question or uh, any clarification? Yeah, let's make this session as interactive. Like a quick recap on partitioning so far. So first, what is partitioning and why it is required? So as our service grows, we will have more data, and that data we cannot store on one node or machine. So we need to partition that data onto multiple nodes, and with that partitioning, we will have more scalability in our service as well as more throughput and more availability. Because earlier, let's say if we have just one machine, so only 100 requests per second were getting serviced. But now since we have more machines, so there is more throughput in our system. There are like multiple ways to partition this. We like talk about partition by key range, and another one was partition by hashing. So partition by key range, as the name suggests, that.
Hey Neha, quick thing. Can we move this to present mode just for the figures to be a little larger?
Okay, sure. Thanks, Lipi. Um, okay, so partition by key range. So as the name suggests, right? It's a key range. So basically, we are dividing all our keys into ranges, and we are partitioning basically on the key ranges. So that means that each partition will have a key range. For example, like A to B will be on one partition and E to F will be on another partition. So the advantage of this approach was keys will be sorted. So in our application, we will be able to make range queries. For example, let's say for a mailbox, right? If the most of the use most of the users, when they open their mailbox, the first request on the storage system will be give me the top 15 messages in my mailbox. So that's a query, kind of query, a range query that will be on the system. And famous storage systems like big table and HBase uses this partition strategy by key range. Then we talk about partition by hashing. So basically, we'll use a hash function. Will on a key we will apply that hash function, and it will give us the node number, which will tell like on which node this key, this data for this key will be stored. Um, so due to this technique, the load on our system will be even, but there will be like one issue which we discussed, like if what if one key is making lot of requests in a short span of time, then one of our partition will become hot. To avoid that, we use the like two digit approach, assigning a prefix to the hash key and then storing the data onto multiple nodes for that particular key. Yeah, so that was mainly on the partition by hashing. Then we talk about secondary indexes. So secondary indexes is basically like we are creating, apart from index on the primary key, we are creating indexes on the secondary columns. So there are two techniques here as well, like either by document or by term. By document means that we are storing the secondary indexes itself in the same partition where the original data is stored. So it's a kind of local index. So in this technique, like advantage will be we will have like read write will be faster because we are writing in the same partition, but while reading we have to read at multiple partitions to collect all the data and return the request. Whereas in the second approach, secondary indexes by term, uh, we will have for the secondary index itself we will have another for that index itself we will create an that data will be stored on another partition. So so basically write will be slower because uh, we are fine for the secondary index itself it is possible that data will be stored on some other partition, and so write will be slower but read will be faster because we are reading all the information on one partition. um, so yeah, that's a quick recap on what we discussed so far in the last 2 weeks in partitioning. Any questions so far before we move into today's topic on rebalancing partitions?
I just want to point out one thing, that I know there was I know of an interview question which was kindly very much tied to what we covered so far. Like if you're given a query, and you have a partition database, how would you, go about, like like a database is already partitioned, so how would you go about, um, answering that query and maximizing, minimizing the response time and all of that. So reading about all this, I see like how that is tightly tied to, these different partitioning approaches or secondary indexes. So yeah, it's been interesting to think like that. I mean, we are learning foundations here, but there are some concepts which directly map to the interview question as well.
Okay, so DB, do we want to discuss that question now or later after?
I mean, no, we don't. I don't want to interrupt the flow. I was just mentioning that, there are sometimes these concepts map to the questions. Just a comment. Yeah. Yes.
Okay, sure. I think yeah, it will be good. Like if we have some time today, we can like brainstorm on
Sure,
that.
sure. At the end, we can talk about it. But I think, but let's go with the flow. That was just a
Sure.
highlight.
Yeah, I think that will be a good like. Are we
Yeah.
able to apply all the what we learned in the sessions to the those type of questions? That would be good.
Sure.
Okay. Okay.
I have a very small question if you can actually answer. So you said that can you go back to the first slide? There you said that your top 50 emails will be in one partition, in the top end, the partition by key ranges. So will that change if I get, so every day the partition would change, or what will happen?
Yes, a partition would change. Like yeah, that's one of the things which we are discussing today. Like,
Okay, okay.
but yeah, I will like discuss on that because the problem with key ranges, with let's say like if with the A name we have more data, so the size of that partition will grow a lot. So main like in there are like in HBase, right, like it provides auto sharding, so that means that it will automatically split that partition into two partitions, so that like the size, so that like one of the partition would not have more load. So yeah, so is, is that like answer your question or?
Let's look at it later. I think when we let's go with the flow.
So one question here. So when we are looking at user email, first we will for that user ID, we want to find what is the partition, right? So can't we partition by hash that first for that user ID, find the shard that will have his emails, right? And then that shard has his emails. So now I will pick top 15 from there.
Um, yes, yeah, actually that all depends on how we design the key, the row key. Let's say if I am designing in such a way that the row key itself will have the timestamp. So, so basically, like in the index itself, I have a timestamp. So that will basically give me, like, for that user, I can just do a range query like that, give me top 50 keys. So you are right, like, yeah, we can do partition by user ID or by key range for that. But I just gave an example, like if we do by key range, this is one of the way.
Okay, yeah, sure.
So just to give one, like, historical background, like I worked on, like, Yahoo Mail, and we moved from the old architecture to NoSQL, and we used HBase, and since HBase is key range, and we made those design decisions, like, okay, if a user, it's a range query, so we'll make our query in such a way. So, but for for that scenario, we can do hash by hashing as well.
Okay, thank you.
Okay. 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 So let's get started on this. So our topic for today is rebalancing partitions. Just to ask anyone know, like, what is like, why do we need the rebalance of the partitions?
Like we are saying, like the data volume is growing, right? So
yeah. So yeah, basically, like, yeah, we discussed, like, one of the partition has more load, so or like that machine got some hardware fault. So in that case, we want to move the data of that partition to some other node. So that approach is called rebalancing. We are moving the partitions, we are moving the data of that partition to some other node. And the minimum requirement of this rebalancing of this rebalancing is that after this rebalancing, like the there should be a fair load of distribution across the machines. Like when we are moving, we shouldn't make in such a way that we are moving all the data around of all the partitions. And second, while this rebalancing is happening, we should that partition still should accept the reads and writes. And once the rebalancing is done, only then the new like the request routing would be changed to the new node, which will now accept the reads and writes. And lastly, like, since we are moving a large amount of data onto the network, our requirement is, like, we should move only the minimum amount of data from any partition, so that it will have less network and disk IO. So those are, like, the minimum requirements during rebalancing. Mainly there are, like, two strategies for rebalancing. First is fixed number of partitions, and second is dynamic partition. Uh, First, like, as the name suggests, fixed number of partitions. So basically, like in the cluster, the number of partitions would remain same. That means that first time, let's say I configure my cluster, during that time I will decide that how many partitions my cluster would have. So let's say that I configure my system and it has 1,000 partitions, and I have 10 nodes in the cluster. So each node will have 100 partitions. So, so this is like every node will have 100 partitions. Now let's say a new node joins the cluster. So now when the new new node joins the cluster, uh, some rebalancing of the partitions would happen. So what would happen, that every node in the cluster would move, like will give some of their partitions to this newly added node, as it is depicted in the picture here. Like earlier we have 4 nodes, and later we had five nodes in the cluster. So earlier, like each node has 5 partitions. During this rebalancing, each node gave one partition to this newly added node. So now after this rebalancing, every node has 4 nodes. So earlier, like we talk about this minimum requirement. So here, like each node after the rebalancing has the same fair load of distribution. Evenly partitions are evenly distributed, and we are moving only the 4 partitions. So we are moving only the minimum data uh, uh, in the cluster. We are moving only the minimum data which is required, not like all the partitions we are moving. Yeah, so that's like basically like the number of partitions in the cluster would remain same. So the important thing here the author talk about is that whenever we are configuring our system, how do we decide like how many partitions our cluster will have? If we
Yeah, I have a
decide,
question. Neha, I have a question here. So does this mean, I mean, is this idea similar to um, the concept we apply in consistent hashing? Like we try to minimize the impact, right? On when we try to add a node, we say that, okay, if I add a node, then only certain number of nodes, in my vicinity will be impacted, would have to be rebalanced, but rest everything in the ring stays the same. So would this idea be similar to that? I'm just trying to think aloud.
yes, so consistent hashing, yes, so that's a different approach. Let me just recall. So yeah, in consistent hashing, what they do, like instead, basically in the key in the ring, it has like different partitions, that like 0 to 10 will be handled
Right.
by node 1, and then 10 to 20 will be handled by second node. And when one of the nodes is added into the system, then they share the keys, but the sharing of those keys in consistent hashing will be the nodes which are near to that, uh,
Right.
right? Or like to avoid some unfair splits, we do randomization as well, like across the ring we
Yeah, I
assign.
mean, I think I can't directly map this approach to consistent hashing because here we are talking about each node, multiple partitions, and all of that. But I was trying to think about drawing an analogy with the idea that in this approach, we talked about, kind of keeping the nodes evenly balanced in terms of partitions and also making sure that when your new node is added, how do we handle it, right? So I was thinking from that perspective, like we are trying to minimize the impact of uh, adding a new node, right? And how do we rebalance? Is that similar? Like from that aspect, at least the concept of minimizing the impact, would that be same for, like, does that kind of, draw an analogy with consistent hashing? Oh,
So in this book, when the author has mentioned a little bit about inconsistent hashing, he has said that it is mainly used for caching purposes, and it is not a good strategy for database sharding.
mhm.
And so I could not properly understand that part, why. And I was trying to read a little bit of research paper of consistent hashing, and they have also mentioned that it is an approach to uh, redistribute the web cache. That if the cache for a particular web service is getting a lot of load, like a particular website or something is getting a lot of traffic, then how do you distribute the cache? And so yeah, I could not understand that why. And every time everyone speaks about consistent hashing when they want to shard the data, but he has mentioned that that is not a good approach and rarely used in databases.
I mean, we read this Dynamo paper, right, where they talked about consistent hashing, but it would be
So he has also mentioned it that a lot of these research paper and all of these people mention consistent hashing, but it's not actually consistent hashing. If you will read the section which he has.
yeah. I would like to refer to that. It would be an interesting one to see that perspective. Okay, thanks.
I think one difference between that rebalancing strategy we are seeing here and what happens in consistent hashing is consistent hashing, you are moving keys. Here in rebalancing, you are moving entire partitions. The keys still, they are still maintained in the same partition, and you are just rebalancing the partition, not the keys. All right, that's a subtle difference in this rebalancing strategy.
Oh, right, yeah.
Yes. I think in this book as well, like after dynamic binding, that author talk about like partitions proportional to number of nodes. So they're like, they mentioned about this, which Alex is mentioning, that basically when new node is added, the keys will move to that new node, not the partition.
I see. Yeah, makes sense. Thank you.
Yeah, even I wasn't like super clear on that approach, but I think and now it makes sense. So yeah, so basically they are saying like if the data volume increases then of a particular partition, then we'll move those keys around.
In consistent hashing, right? In consistent hashing, you are moving the keys, but this is what Alex has mentioned, right? But I think in here, you just point that partition to a different node, but the key will map to the same partition, right?
Yes. So can we say that like that yeah, I think because like author did mention that like moving of the keys they do in Cassandra, I think. So can we say that like it's a kind of consistent hashing, but like a different?
I think the way, there is a subtle difference, right, that we talked about, that Alex was mentioning about moving keys versus partitions, right?
Yeah. So what? Yeah. Right. So what I was saying, like that moving of the keys, so that's a kind of consistent hashing, but it's a different variant. So that is applicable for databases as well. Can we?
That's a different discussion, right? What Abhishek is mentioning, that this article which says, don't, use consistent hashing in databases. That is an interesting, like, I haven't read it, but it's seems to be an interesting read about what they're saying.
Okay. So yeah. So yeah. So in the fixed number of partition, one another point which author mentioned in the book is like how do we decide like the number of how many partitions the cluster would have, because in this strategy I won't be able to change the number of partitions later on. So if I decide like the number of partitions will be a lot, then like the partition management, there will be partition management overhead. If the number of partitions are more and each partition would have less data. So then there will be partition overhead. But if I keep my number of partitions lower, and then each partition would have more amount of data, that is the partition size will be large, then in that case, while we are rebalancing will be expensive because I'm moving a large amount of data onto the network. So deciding the number of partitions while configuring the cluster is like a tricky thing. We have to be very thoughtful on like what will be my partition, like how big my partition size could be in our application. Based on that, we need to decide on the number of partitions in the system. Yeah, so that's pretty much on the fixed number of partitions approach. Next is dynamic partitions. So dynamic partitions, as the name suggests, right? So let's take an example, like for the let's say if my data in the DB is partitioned by key range, as we earlier discussed, right? Like if A have more amount of names, more amount of data, so one of the partition can be skewed. It will have more data. So what HBase does, that it will divide that partition into two parts. Whenever the size of the partition reaches some specific threshold. Like in HBase, they mentioned that the threshold is 10 GB. That means if whenever the size of any partition grows to 10 GB, then it will split into two partitions. So, and when similarly, when the partition data is shrink, there is very less data in one of the partition. There is a minimum threshold for that as well. Whenever it reaches that minimum threshold, then it will get merged with another partition in the cluster. So by this way, what we are saying is like our partitions will be dynamic. The number of partitions in the cluster will be dynamic, which will totally depend on the data in our system. So let's say if my service is growing, I have more data, then there will be more partitions which are splitting. So I will have more number of partitions in my system as compared to other approach where we had the number of partitions are fixed. So in dynamic partitions, the number of partitions is directly proportional to the data volume in my application, in my cluster. Is any question about this dynamic partition?
So once we split the partition, then and how do we give it to the nodes? Like then we need an extra node to store that additional partition. Because so see, so my understanding, these nodes are the machines, right, where we're storing data, and partition is a logical entity, logically how we're splitting. So now once we have splitted our logical entity into two parts because it has become bigger, we need another machine to store that partition, right?
Yes. So yes, so what will happen, like let's say one of the machine which has more data, so that partition will get split, but there can be other machines in the cluster which has lesser load. So that partition can move to other nodes in the cluster. And there will be like let's say the like overall, if there is no partition in our cluster where sorry, no node in the cluster where this partition could go, so there will be admins who are monitoring the overall health of the cluster. When they see that the each partition is their maximum threshold, then at that point they have to make a decision to add new node in the cluster.
Yeah. Okay. So is there some central management service running which is keeping track that, hey, these machines don't have more capacity, so we can assign partitions to these machines? And so like someone should know this information. Like, is that information generally kept at each node level, or is there a central service which keeps that information?
So how that node assignment like happens, that I'm not sure, but there is uh, uh, like in HBase, zookeeper basically keeps that information.
Okay, so
That,
there is, yeah. Okay, so then
yeah,
you're saying, okay, so there is this central service which has that information, right? And you go to that central service zookeeper to find out. Uh, but yeah.
but yeah, the part which I'm not sure whether it keeps the size, right?
Mhm.
I'm
Oh
sure
yeah.
it will be. I'm sure it will be, because let's say node 0 has more amount of data and it is splitting. So node 0 will can access the zookeeper, and now from the zookeeper it knows the entire health of the cluster, that how much data is available on each node. Based on that, it can assign the partitions.
Okay, okay, yeah. I'm sorry, I think I jumped ahead. Yeah, okay, this part was mentioned here. Like, where is that knowledge kept? Okay, okay, yeah.
Yes, yes,
Yes, okay. Yeah, yeah, this has this part. Okay, thank you.
yes. Yeah. So there is a the cluster, we call that as a cluster metadata. That cluster metadata is stored on the zookeeper.
Yeah, okay.
Makes sense. So yeah, that's like actually pretty much on the dynamic partitions. Yeah, so here in the dynamic partitions, like the number of partitions in in the cluster will keep on changing based on how much data we have in the cluster, like based on the applications, as the application grows. um yeah, that's pretty much on dynamic partitioning. One thing more which author mentioned, like where, so in the fixed number of partition approach, when we configure the system, we have like initially we have to specify like 1,000 will be the number of partitions in my system. But for dynamic partition storage systems, uh, we have like a very small, we basically start with very small number, like very small number, like let's say X. And since it has that splitting or merging strategy for the partitions, so as the system grows or the application grows with that dynamic partition, our system grows with that. But we initially start with some minimum set of configuration. Any
Yeah, I have a doubt. This in dynamic partition, who makes the decision to? So zookeeper will make a decision to split, or zookeeper is just to bookkeep. It's
Zookeeper is only for the bookkeeping. The part where the partition itself, when the partition itself, when it will grows to the certain size, it will split into two parts. Zookeeper is just for the bookkeeping.
okay. So the responsibility to split itself is with the
With the
partition. Okay, so you for with that, I think you mean the driver of the database. Maybe that is that. I might be wrong. So someone must be doing it, right? Okay,
yeah,
the partition. Okay,
So
okay.
for
like I
each
like
each
like yeah in HBase there is a concept called region server. So that server basically, because the data in HBase, the data, actual data is stored on HDFS, those file systems, right? On those files. The partition data is stored on HDFS. So the region server is a process which is running on web server, like on that machine itself. So that region server is basically manages all those things. That okay, the like each region server is responsible for one key range. and like A to B. Let's say one region server is responsible for that A to B key range. So that particular process will monitor itself, like, okay, how much data I have. If it exceeds that particular threshold, it will start splitting. And it will start splitting, and as well as it will update the zookeeper that, okay, now my partition has changed. Now I will be responsible only for key A, and this is my IP, and other information will also get updated. Does that make sense?
Yeah, thanks.
So one more thing we can probably discuss here is, I think the points which you mentioned before, that when we are rebalancing, we have to keep on serving the live traffic, right? So like, how is the process of rebalancing that we are not interrupting the live traffic?
Right. So once the partition is moved, or let's say in dynamic partition, when the partition is split itself, so after the splitting, once the, like in splitting, like the data will be moved for that split part to some other node in the cluster. So once that is done, then only there is a request routing table as well. We will discuss on that later. So that table will get updated, that okay, now I'm responsible for only key range A, like the zookeeper, right? So I will be responsible for only A. So now the live traffic for that node 0 will only serve now A request, and all B requests will go to the another node.
Yeah, okay. Yeah, no, yeah, that's right. I was just wondering that, like, when you're doing these partitioning and when you are sending the data to other node, that process will take some time. So during that time, what do you do? Like, so let's say, so like
The
in
book,
your example.
yeah, I think in the book they mentioned that you keep serving from the original, like you don't just move the, you don't change the direction until it's completely moved, and then you redirect your request. So
What?
during that phase of transition, you don't want to interrupt your reader, right?
Uh, okay, I think if you will read and write, if you will both the things, if you will keep at the same partition as before, then uh, your rights will your rights will keep on increasing, or will they saturate after some time? Like, I mean,
I see your point. So I think there is a concept called snapshot. So let's say when the rebalancing started, the region server will take a snapshot of that region, and then it will move that snapshot to another node. Then later on, when that snapshot is moved, there will be some delta, because that node, the original node, is still serving the reads and writes, right? So there will be some delta, and later that delta will be moved, something like that.
So one question here. When you say HBase has data on HDFS while only partitions are handled here, what are we talking about moving? The data won't be moving, right?
Oh, so data won't be moving. Yeah, that's why, like, the data won't be moving.
Yeah, data won't be moved, just that ownership will be changed in the zookeeper.
so what? Okay, let's look at this fixed number of partition. Data is moving to the different node, right?
So in HBase, the question is regarding HBase, right? So that's why I was saying that. So in HBase, the data resides in HDFS, and the ownership actually resides in the zookeeper, that is information. So data is never moved between machines. It stays in the HDFS itself, but the ownership is transferred to a new machine.
So if the data is not moving, then what are we rebalancing if the data is like is on the same machine? So we said that we are getting very high load for writes or reads, right? So we want to redistribute the data. And now if you're saying we are keeping everything on the same machine, we are not changing, then what are we actually doing? Like how?
So,
No. So yeah, they I'm not like sure on that, but yeah, what Abhishek, like the node on the node there will be region server, so that's a process which is responsible for splitting and ownership and all that, but the actual data will be stored on HDFS, another, like, it's a kind of file system. So whenever like we have to store some data, from that region server will store the data onto HDFS.
Yeah, I mean, in this scenario for HBase, I think HDFS is taking care of keeping the replica copies and balancing and everything. Because
so
But I think it is confusing. Like if we are talking about HBase here and like we are abstracting a lot of things that it is taking care of rebalancing, then I mean, then it confuses. At least to me, like because here it clearly says that so data is being moved from node 0, that P4 has moved from node 0 to node 4, right? So that clearly says that the data has moved.
So there is a difference actually. So there are different kinds of databases. Here, HBase is backed by HDFS. But if you take Cassandra or something like that, which is not based upon HDFS, the data actually moves. But here, HBase is, since the storage is backed by HDFS, there won't be any movement of data. Just that they create some files that are like symlinks, you can say.
Mm-hmm.
So that kind of creation is done in the backend, so that new reads will only be served by the new server whenever it takes hold of that permission ownership.
So is HBase doing fixed number of partition, dynamic partition? What is HBase doing? What strategy is it using?
HBase does
So
dynamic partition.
Okay.
yeah. So each partition, I mean, there are different strategies. So one of the strategies like the size, based on size. If the size goes beyond a limit, you will split kind of, I mean, splits or merges.
I think
Okay.
maybe we took like HBase example, but like as someone mentioned, right? Like there are like other, like Cassandra or other, where the actual data is moved. So in, like, if we just talk about theoretical approaches, in dynamic partition, data is like in both the approaches, data is actually moving off that partition. So in HBase, maybe HDFS is automatically taking care of how the data is moved, because region server will change the mapping in the zookeeper, and internally HDFS takes care of it. But in general, in the dynamic partition approach, like in both the approaches, data is actually moving.
Mm-hmm. Okay.
So one question over here, like when we say partition movement and all, like these databases also have these caching layers in between, right? They get refreshed or impacted while doing this. Like HBase has a heavy in-memory usage of data as well. So when partition happens, what happens to that?
So I think, yeah, what what my thinking says, like basically when the region server is moving the partitions, it basically takes a snapshot, because the actual writes are still happening on the original server. So that particular snapshot will be moved to the new machine, and then the delta would be written. Then the delta which is in memory uh, or which is there on the original node, that will be moved later on.
Okay, thanks.
So my my take on this question is yes, it is affected, and that's why we try to minimize the movement. So like initially on node 0, like if we look at this diagram, initially for P4 partition, all the cache for P4 data was on node 0, and now because P4 has moved away, so that I mean, that cache is not useful, and node 4 has been recently created, so it would not have the cache. But that's what we have tried to do, that by moving the minimum amount of data, we have only invalidated like minimum number of cache. So only the P4's cache is now not useful to us in node 0.
Also, I think when when it completely move, then let's say the cache on node 0, based on the most frequent use, the cache used to be in node 0 now moved to node 4 is no longer used, and that's gonna be replaced.
Yeah, that will be replaced by the other ones. Yeah.
And then the cache from node 4 will gradually build up.
Yeah, exactly.
Our traffic is now, for the data to on node 4 is completely routed to node 4.
So basically, we are saying like the cache data will be invalidate and
will not be useful. So and it will take some time to rebuild it. Yeah. So see, basically, let's say P4 had key X, right? So now because we have moved the data, so key X, we will not go to node 0. We will go to node 4, and node 4 does not has any cache for key X. So key X cache will be built eventually in node 4. But on node 0, we will see that key X, which was cached, it is not being used for a very long time. It has not been used for a very long time because nobody is accessing that key, right? Because we know it has moved. So after some time, it will be removed from the cache, and it will be replaced by the frequent keys for P0, P8, P12, P16. So yeah, so eventually our cache will be then properly maintained.
Okay, I think there were two things. I think there was another, earlier you asked one more question, right? Like I was thinking mainly about, like I was thinking on that direction as well. Like let's say like when this P4 is moving to node 4, at that time it is still serving the P4 partition. So what if there are some writes of those P4? And since we have moved that P4, but other nodes partition are still moving, so what will happen to those writes, so that those writes won't be on node 4? How that is managed? I was thinking of a snapshot approach, but
so snapshot moves data, right? Snapshot, I think, does not move cache as far as I know.
No, yeah, cache question is different. That I think
okay.
That is different.
Okay, so for that, yeah. So I think the other approach could be that, and I don't know if this is the right approach, but so for like when we were moving P4, right? So when we have started the move, we can say that all the writes for P4 will now go to node 4, right? And all the reads will go to both node 0 and node 4. So any new data for P4 will be moved, will be added to node 4. So all the writes are happening on P4. But when we are reading, we have to look at both node 0 and node 4. And once the data movement is complete, then we switch it to node 4.
But
Yes.
writes cannot happen till all the data is moved, right? We should have
Yeah.
that.
Okay. Yeah. Yeah. I
that
think it. Mhm. Yeah, it's a problem, I think, because what about updates? How will, because update, that data is on node 0, and how will you update it? Okay, so then you are, I think, yeah, then we have to use this snapshot approaches, like to take the snapshot. Yeah, okay, I think, yeah, you're right. We have to take the snapshot.
Yeah, even like with snapshot, I think I see some problem, like because when we move the snapshot, even after snapshot, there will be some delta. So how that delta will be moved to
Yeah,
node?
so that's what they say, right? First you move the snapshot, so that is the major chunk. Then whatever is the delta, so that delta, you know that up till this timestamp you have taken the snapshot, and that write ahead log has all the logs which happened after that snapshot. So you replay those logs on node 4 also,
Yeah.
so that it get all the new writes which happened.
Yes. So once we move that write ahead log file, then only node 4 will start accepting the new writes.
Uh, yeah.
Okay. 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 Yeah. Okay. So yeah, we can look more into that. But any other questions or before we move to the next part? Okay. So so next thing is request routing. So basically here we are saying that now we are doing this rebalancing, right? So partitions are moving around in the cluster. So when the client makes a request, how do we manage those partitions? How do we know that now this request has to go to either node A or B? So for that, like earlier we discussed, right? Like there will be some service which would maintain this information. So there are like multiple ways of doing that as well. The first approach is let's say each node itself knows about that partition management, like the partition tracking. Like each node is aware of that partitions. So then a client can make request to any node in the cluster, and then that node would know that okay, I don't handle foo request, so foo request is handled by node 2, so it will forward that request to node 2. And let's say if client makes a request directly to node 2, then node 2 knows that oh, I handle foo, so it will serve that request. So each node is actually aware of the each partition, so it will handle request based on whether the request itself it handles those key or not. If not, it will redirect that request.
So when you say forward, request from to node 2, so when node 2 get the response data, it have to send it back to node 0, and node 0 send it back to the client?
No, it's a redirection request. 30, yeah, 30.
So okay, so the client have to make another request to first make a request to node 0, and then make a request to node 2.
No, I think then node 2 will directly return to client because it's a redirection.
I don't think node 2 can directly send response to the client, because the client only trusts node 0, right? It know that it make a request to node 0, not gonna accept the response from other node. Would be security.
Yeah, I think one way that I think what Neha you were saying is that when you get a request on node 0, and because partitions are aware, let's say, about where the data is living, So node 0 can possibly send like this first figure, right? It says who lives on node 2. That's more like, it's not a redirection, it's just a knowledge, thing. And then node 0 tells client that, hey, contact node 2. And that's where the second figure comes in. I'm just thinking if that's the case. And then the client here, the routing layer says, okay, I'm going to contact node 2. And then that's where the client does that.
No, I think it's not like that.
Okay.
These are three different approaches.
Oh, really? Okay.
Yeah, they are three different.
Yeah, these are three different approach, three ways.
Oh, I see. I see.
Yeah,
Oh,
yeah.
yeah, it's written in the caption. Yeah, sorry.
Yes, yes.
Okay.
Yeah, I think it's a like from when the node 0 gets a request, it's a redirection 303. If I'm not wrong, like 303,
Yeah, so
node 2 will return to node 0 and then to client. That part I'm not sure, but the
Yeah,
part I'm sure that it's a redirection.
I'm sure it will first return from node 2 to node 0 and then to the client. That's what I read in the book.
Okay, okay, okay.
Yeah.
Yeah.
but okay. Why is the problem if node 2 returns the data? Because for the client, I'm overall serving as a system. Like he does not care which node, which node is serving, right? So
And that is where the routing tier is coming in, right? To the client, you want to be transparent. You want to hit a particular node. But if I have a routing tier which takes care of, okay, I just want foo data wherever it lives, just contact that and get me back, right? Isn't that the second approach here?
Yeah, that's a second approach. I think that so we can say like that's a problem. Like there will be
Yeah.
too many hops with the first approach, because first if the request goes to the node which doesn't handle that request, then there will be many hops, like at least 2 hops. So this request will go to node 2, then it will return back and then to the client.
So, I think so. One thing is, it is saying that each node has the knowledge that where data lives. So I think probably in like one another hop, it will know that where the data is. But the problem I'm seeing is that so when we are rebalancing, how will we like atomically update? Because all the nodes should be updated with that knowledge together.
I think she might be coming to that next.
No, that is a different approach. But you have to solve this problem in first approach also, right? So this is the problem, and you have to solve this problem in first approach. It's not that first approach will not solve this problem.
I'm not saying that. I'm saying that the rebalancing aspect in request routing, I don't know if there is more coming up. I don't think we are talking about all of that in this slide here, right? Isn't
Yes,
it
yes.
just covering the basic here?
Yeah, DP, you're right. So there are like 2 ways of that knowledge as well. One is Zookeeper. Like Zookeeper will have that updated cluster metadata, and each node will go to Zookeeper for the new updates for any request. Second is which Cassandra uses, the gossip protocol. So whenever any partition is changed, every other node will be updated. So like each node knows the partition, like the partition tracking of the entire cluster. Yeah, so basically like, yeah, we can say like in the first request, like there is like another service which would know by that, like each node is aware of that partition like tracking. So each node is basically aware of that, and yeah, so using that knowledge, it is rerouting the request. So that's the first approach. Second approach is, instead of each node having that knowledge, we have a routing tier. That routing tier is responsible for the entire cluster metadata, like which node has which region, which keys. So client will make first request to that routing tier, and then that routing tier would knows that this key relies on which node, and it will redirect that request to that node. So that's the second way. Third way is where the client itself knows about the partition. Uh, so since client already know about it, client will directly make request to node 2. Okay, so yeah, these are mainly the like 3 ways in which request routing can happen. So as we earlier discussed, right, like how this service discovery would happen. So like many of the storage systems uses Zookeeper for that service discovery. So here, as we discussed earlier, right, like the Zookeeper is storing that cluster metadata. Like it has this information that this is a key range, this is the partition, and this partition is on this node. So Zookeeper maintains this information, and Zookeeper, if in the system we have a routing tier, then Zookeeper will update the routing tier, and based on that, the routing tier will route the request. Or in like in HBase, there is no routing tier. HBase actually uses like each region server has that information, so each region server will actually uh, HBase, like each region server will will read that information from the Zookeeper and route the request. So that's how like some storage systems use this Zookeeper for the cluster metadata. There is another approach which I mentioned earlier, like Cassandra, they use the gossip protocol, in which whenever the assignment happens, it updates each other. So each node is aware of every other partition. So yeah, so any question on this or on the request routing part?
So the first one is similar to what Cassandra uses, right? The first approach. Probably here will be a gossip protocol, and then node 0, node 1, and node 2 will be interacting with each other. And then forward the request.
Yes.
Right. I was thinking like in which use cases will be using these 3 approaches. Like for 1 and 2, like it's approach 2 and
Sorry, Shah, the voice is breaking. Can you repeat?
Yeah, I think she asking, the use case, which in the use case for using each approach. When we use approach 1 and when would we use approach 2?
I think it depends on the like application or the system, how you want to design. I'm not aware like of the third approach being useful, like how would client would know the DB partitions. I'm not sure like whether this would be really useful in any application, but 1 and 2 sounds like more useful ones. I think to answer your question, it depends on the application and the storage system, how we design. But
Can you give an example?
So in approach 3, actually Cassandra uses approach 3 as well, where you have the driver which is aware of the token node. So it's not like one approach is defined for a system. It depends on what strategy are they using. So
yes, so yeah, right. So I can talk about like the HBase which like we used. So we didn't have this routing tier, but the like in HBase, like HBase by default uses the zookeeper for the cluster management, and each node is aware of that partition assignment. So essentially we are using the first strategy. HBase uses the first strategy where each node is aware of the partition assignment using the zookeeper, using the service discovery through zookeeper. So client will actually make a request to any node, and that node, first thing we do is like we check whether can I handle this request. If I cannot handle that request, I will redirect that request to another node, which will, and since every node is aware of the region assignments, so partition assignments, so it knows exactly which node can handle, so it will redirect that request to node 2. So I think I recall a little bit. So yeah, the get request will not be a problem for the redirection, but for the put request, there was a problem with the redirection as well. So yeah, like how, because with the post request, there will be data in the HTTP request itself as well. How we will move that, like the post request in the redirection itself. There are some like strategy to do that, but yeah, that's how it is done in HBase.
What the advantage of approach 1 over approach 2? Because what I see is for the approach 1, the client needs to know all the node, right? Even like, it can send a request to any node, but it needs to know like how many nodes are available.
So here, are we thinking about the client will be the browser always?
No,
it's not the browser.
Yeah, it like definitely it will be a load balancer. So basically, what essentially we're saying, like the load balancer can assign the request to any node in the cluster. It need not to forward the request to the node which has the required partition.
I think it's not the load balancer, it's your app server, which actually writes the information to database.
It can be anything. It can be load balancer, client, browser, driver. It doesn't really matter.
No, but
it's just abstraction. You get a request, and you need to somehow route this request to some node in your network. So the point is how you handle the situation where the node contacted doesn't have the data anymore because it was rebalanced to some other node. That's the main point here. So in the Cassandra, which seems to be the case of a model 1, what we have here is a ready infrastructure to route requests based on concepts like distributed hash tables, peer-to-peer networks that contact neighbors to figure out where data can be found. So there is already an infrastructure for that, okay? And that infrastructure can also help solve the problem when we rebalance data on our cluster.
Yeah.
Does it make sense?
Yeah.
Yeah, so I think it can have like the ring strategy or ring topology, wherein if one node doesn't have information about that, it can ask its neighbors, as you were mentioning.
So is there any other topic, Neha? Just checking that you are yet to cover, or?
No. I think that's pretty much.
Okay. Just making sure.
Yeah, I think that's the end of this. And there's nothing more in the chapter. There's actually one thing which I missed. So this rebalancing, like they mentioned, like, do you think like this rebalancing should be automatic or it should be manually done? So I think that depends on how the storage systems are designed. So they mentioned like few storage systems like Cassandra and other, they basically suggest the partitioning, but they still need a human intervention where the administrator will see like those partitions are correct or not, and they will commit. But like in some HBase, that is all automatically handled. So
Yeah,
that's pretty much for
that's
this.
one thing that I quickly want to touch on. I mean, I don't. So the earlier thing I was saying about the how to map these concepts to, in general interviews. So I am not sure if there can be, just to be clear, I'm not sure if there can be an independent, question on this. I, never heard of anything like that. But I was just trying to say that a lot of concepts in this chapter we have learned when we talk about, like, in the other sessions we have on system design, we go through these problems about mock interviews and all of that. And I feel that a lot of times we just say, okay, I'm going to have sharding and distribute my data. But a lot of concepts that we covered in this chapter can be really useful to, if somebody really wants to go deep into partitioning and all of that. So that's where I wanted to say, like, secondary indexes, this balancing approaches. That was, I felt that there was a lot of good content in this chapter. Um, if somebody wants to dig deep into partitioning aspect. But yeah, I mean, I'm not sure if there can be an independent question on this, but yeah.
Yeah, I think I agree, because for any
So
system.
I have I had an interview last week, maybe not related, but I work on Elasticsearch and work on NoSQL systems. So interviewer was poking me on how these partitions happen, how the shards are maintained. So they were going deep into the buzzword that you're using in your resume. So at that state, you may need this knowledge. So
Right, exactly. That's a good point. I don't know who was talking. Maybe Ajay, or yeah. So yeah, that's actually interesting that going deep into, if you mention distributed systems in your resume or stuff like that, then this knowledge can be very useful for deep dives.
Yeah, you might be asked to solve some problem during interview, and say the interviewer asks you to not rely on any centralized solution.
Right.
So imagine any centralized solution that tells you you can't use Zookeeper. You need to pick up some other database that doesn't rely on Zookeeper, because Zookeeper is a centralized solution. So we are not, in fact, discussing implementation details, but you need to make decisions that, in a certain sense, requires you to know about that stuff, rebalancing stuff, and how it works.
Yeah.
So it's a tricky situation, because you need to know the stuff in order to make the best decision or pick up the best choice.
Sure. Yeah, so the concepts here are, pretty neat that way. Great. Any other questions, anyone?
Right now, when we talk about, like, when we repartition, we have to move data to different machine, right? But I think someone would talk about, like, we keep the data the same on the same machine. I think that's a neat feature, right? Because maybe that if we keep the data on the same machine, but create like a mount point, from the new machine to that one, and get the data from there. Just like a network mount for the file.
I think that's not the case. I think Uday mentioned that is only applicable to HBase.
Yeah, but I'm asking, you know, could that approach be feasible? I mean, you know, we have a machine and a different mount point to different.
It's not sure about, but you can think about only for the files. What about because the database have their own internal structure. It may be just a single file from database point of view.
And also they don't do mounts, maybe because we have the principle of data locality. I mean, data should stay near to where the computation is happening. So in terms of HBase is the HDFS, it keeps the data, and when it runs the job, it runs where the data is living instead of fetching it from the network, and it's skipped as a last option. That's what I think.
All right, seems like this change of time helped. We are like, took almost an hour to finish this, but any other questions or comments before we close for today? So I see we have let me stop the recording. If there are no questions, I'll stop the recording.